Alrighty then. So last time, we ended up getting kind of frustrated. We're building. I guess I should start with what we're doing. We are building a um, flying movement 6 degrees of freedom component for a pawn in Unreal 5 to try and kind of recreate Descent in Unreal 5 and make um, a modern platform that we can load all the Descent levels in and play them in. Uh, and in the process of this, I've been extremely frustrated with getting movement rotation set up, rotation input in particular. Um, I've been trying a lot of things and none of it's working at all. And so last night, after I closed the stream, I went back to the beginning and started playing with rotation again, messing with a bunch of things, doing a bunch of research, and I figured out what was going on. So there are three ways to rotate an actor in Unreal, or three basic functions. We have set actor rotation, add actor local rotation, add actor world rotation. So set actor rotation sets the world rotation of the actor, just directly, no questions asked. There actually are a few questions asked internally here, but it's going to try and get the actor set at the location you gave it, no in between. Add actor location is going to take the current location and add your rotation to that current, or add actor local rotation is going to take a local rotation you provided, transform it into world coordinates, add it to, transform it into the actor's coordinates, and then set the actor's rotation to the local rotation. Add actor world rotation is going to add a world is going to add your rotation in world coordinates to the actor's rotation. At the very, very beginning of this, I decided that I wanted to do one movement and set function. I looked into the implementation of the code and found that the movement and rotation set functions internally are combined together, right? So if I call like an add actor location, and then I call an add actor rotation, that will set the location twice. It will set it to the whatever input I gave location, and then it will set it to itself on the add actor rotation. And my thought was, well, if I'm in C++ anyway, with the capability to combine these, I should do that. That turned out to be a massive mistake. That's the problem, is because the location I'm adding to world. But the rotation, if I try and add to world, it is nearly impossible. I've not figured out how to do it, to get the correct adder. Right? I can set the actor rotation to exactly where I want. I know how to get that. I can add the local rotation. I know how to get that. But getting this one requires a ton of very difficult math. So we take the simplest route for maintenance, simplest route for what we'll be doing. We will not be using the combined function. We will use two functions. I think I'm going to add actor local rotation simply because it does some nice stuff in the background to make sure our adding is not going to rotate us like through an object, stuff like that. So we're going to need to transform this pawn before we go to C++, but let's walk through what kind of work we'll be doing with C++. Okay. So in C++, what we'll be looking to do is something similar to this. Actually, something quite a bit more complicated to this in tick. Doing it here means that the acceleration and deceleration will get applied properly. But this is the kind of the basics what we're looking to do. We're looking to take our input values, add them to our angular velocity, clamp that angular velocity to a max, and then add actor local rotation from the rotator that we create from this vector. We'll go ahead and make here we also set old rotation before we do the rotation, because we're going to need old rotation to calculate angular velocity. Angular velocity has not yet been calculated. So every tick we want to calculate angular velocity. This is calculated per tick. And angular velocity is going to be the old rotation rotated by the inverse transform of the actor. Now, that's the second problem I was able to... Now, to be clear, this should be... we should rotate with the delta of the current rotation in local space. But the current rotation in local space is always zeros, so we don't have to do any deltas. Simplifies things a little bit for us. Now the second problem I figured out is I was trying to rotate rotators by rotators. For reasons, I'm coming up with a tutorial script that I'll be explaining rotators in, and for reasons I'll explain there, you have rotating a, well, you can rotate a rotation by a rotator. That only works if your actor is at world coordinate 0, 0, 0. Right? If you're considering the actor's rotation, that assumes the actor is at 0, 0, 0. And so you need to get the transform if your actor is anywhere else and rotate it by the transform. And then that's going to work no matter where the actor is in the world. Technically, it even works after you've done like a perspective transform. This is before the perspective transform, but fun fact, perspective transform is just the same transform that we're using for the actor here. So you can actually do all this rotation in a perspective view if you want, and it still works. Should still work. Won't guarantee that, but it should. Okay. So all this needs to really happen every tick. The only thing that we need, this needs to happen every tick. The only thing that we really want to do here is add the actor local rotation. Basically, we want to do just this, and we want to skip this too, because we want to do all this in C++. I'm not going to delete it yet because it'll be a nice reference for what we're doing in C++, but all of this needs to be done in C++. Okay. The reason that we're doing it in C++ is to make it easier to like apply to other things. So for example, this is the base for the player ships, but we also want to apply this flying movement to the base for the robots. Okay. So the place to start here is in our tick. We are looking for, so there's our delta, Here, we're looking for this. We want to split this out. Just like this. Okay, so we have a delta rotation. and we have a hit result. Um, and the hit result is, of course, passed by reference. Or not? What doesn't like about that? Oh. Ah. Usually, JetBeans manually corrects the pass by reference, but apparently it missed it this time. Okay. So, this is our primary change. We are going to do the rotation in a separate function. This does not mean that we fixed everything yet. We still need to go back through and fix this. So, let's do this. Move to, or I should actually put it up here. We want to know if we want to separate the if statements. Oh, and we still need to handle the angular hit result. Separate and separate with an A. Funky. All right. So with these separated out, we can do this much cleaner. So let's go to all this mess. Go away. Let's remove the breakpoint for now because we're just going to be deleting a lot of this. So we don't need quaternions here. We could use them, and there might be reasons for them to be very useful here, but for now we don't need quaternions. I just realized something interesting. If we take a look at the little reference I built here, we need to be able to add these two together. You can do that with rotators, but it's a little bit messier than doing it with vectors. So that means our input needs to be a vector. And our angular velocity needs to be a vector. Ooh. Ah, that works. Yeah, that works. So let's change all this around. So Where is it? There you are. That means that this needs to be a vector. This needs to be a vector. This needs to be, yeah. This needs to be a vector. Bool, bool, void. Add rotation input needs to be a vector. F vector local pitch yaw roll. Angular speed is good. That's actually going to make angular speed so much easier. This was an experiment, so this can be going away. I can probably put this away too. We'll just leave it for now. We might need it later. I feel like I'm missing some vectors somewhere, but hey, compiler, tell me soon. Okay, so that's simple enough. What do I call this? Local pitch yaw roll. Pitch yaw roll. Okay. Pitch yaw roll. Okay. Okay. Is exceeding max angular speed, flows to angular speed. Angular velocity dot size squared. Angular speed. Okay, okay. I think that's right. I'll have to check on that. Exact from angle, we aren't touching. This is going away. Alrighty then. Now our big one. So rotation acceleration is get pending input. And then what we want to do is get the size so rotation acceleration dot size squared is greater than 0 dot f. then we want rotation acceleration dot size. Oh, wait, what? This might work. Okay. Good. So analog input modifier is greater than 0. Well, let's actually drop this down so we got more room to look at stuff. And we're not exceeding the max speed. And if oh, sorry, angular velocity dot size squared is greater than 0. Now this is where we go different. Okay, what are we doing up here? We do time scale, control acceleration times velocity dot size minus velocity. So it wants our control acceleration to be between 0 and 1. That's interesting. That makes sense. Okay. All right. Times velocity dot size minus velocity. Times time scale. Interesting. So this is where we apply our input. This is where we apply our time scale. I think I'm going to try and simplify this function and go ahead and delete all this time scale stuff. Okay. Oh, whoops. Wow, that gets rid of a ton of code. Okay. If um, where did I get this? Oh, I see where I got this. Because we're not doing this. Yeah, okay. So, if we got this, then old angular velocity is equal to angular velocity. Delete that mess. Constant float, velocity size, angular velocity size is equal to the max Okay, I'm thinking I might be missing something here. No, I'm not. Okay. I'm confused. I suppose that kind of makes sense. I was just confused as to why anybody would input. Why would we would be concerned with people inputting negatives for deacceleration, and then I realized then because then you would never slow down. And that's actually problematic. Oh, and here's where we diverge. This doesn't do anything. Right? This doesn't do anything. Angular velocity equals our angular velocity times our angular velocity size. No. We are looking to add rotation acceleration onto our angular velocity. Now, there's a few things we need to calculate rotation acceleration, but we're looking to add it on. So, equals angular velocity plus rotation acceleration times angular velocity size. Right? Because our rotation acceleration got clamped to a size of 1, but then we did some manipulation to get the right size by adding in the deacceleration. What? Why? Once again, this is wrong. We want to take our rotation acceleration dot size and multiply it by d. Huh. That's not right. What if we don't have an input? We're not supposed to have an input here. We're not supposed to have rotational acceleration here. What we need is to deaccelerate. We need to take the angular velocity and lower it. So we want to move it towards 0. Okay, once again, this doesn't make sense. I'm not adding these two together. Okay, so my concern with this is that without getting the normal, we have the potential for this to be above 1. Both of these to be above 1. So multiplication isn't necessarily going to work. Could divide. But then if they're below 0, that's a problem. Could subtract. Subtraction sounds sensible. We are guaranteed that it's positive. But then why am I subtracting this angular velocity size instead of just the acceleration times delta time? Well, yeah, why not? Drop this in here. We're going to need it in here in a minute. If yeah, that all makes sense. Holding angular velocity. I actually think we do want to get the safe normal on this one. Oh, no, 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 no. Well, shoot. What am I doing? If we're exceeding max speed, exceeding max angular speed, this all makes sense. Oh, I'm confused why this is twice. Might have to look into that. For exceeding max angular speed, remember we have a local rotation. What does this do? It doesn't change let's see. So basically we deaccelerate, but okay, so we're deaccelerating. But if we're above the max speed, then we want to lower our velocity to the max speed. There's just one problem with that. We're local. This is a local change. Okay, so right, all of the angular velocity is going to be in local coordinates, and max pawn angular speed is just a float. That might be trouble, boys. I'm not sure quite how to compute that. So this is the max speed that we're rotating around. Being in local coordinates doesn't change the size of the thing. The size of the thing is still fine. Okay. But we're setting this to a change. And we want to change we want to lose the difference between our current speed and the max speed. Current speed and the max speed. Yeah. Yep. So we want to drop very quickly. We want to suddenly hit this. Except this is a change in. No. So we need a vector. No, that doesn't. That doesn't make sense either. I'm losing my marbles. We are going to come back to this later. Okay. Acceleration times delta time. Okay, so four errors. Mm. Not quite sure how to do that yet. So we're going to hide this one. Basically, we're not going to have max speed limits to start with. All right, this is where we get interesting. So angular velocity is going to be equal to okay. Old location, old rotation, old rotation. Let's check and make sure this does what we think it does. Nope, it does not. Five. We want to rotator to pitch yaw roll vector. Hmm. So in blueprints, we transform into a vector by breaking the rotator into roll pitch yaw and then making a vector. That is super ugly. I was hoping that there's a better way to do it. This does not look right. I don't think this does what we want it to. Yep. Okay, so um I really wish you would stop doing that. I need to look that up. Yeah. Pitch. Roll. Got these backwards, didn't I? Roll. Then pitch. Then yaw. I think that works. We have to invert it for reasons I don't quite understand. But we do. We have to invert it. So, I think that there are ways that we might end up converting angular velocity back into a rotator here eventually. We'll have to do some experiments. No viable constructor for quaternion. What do we have to do? We have to convert this to a rotator. And the reason I think that we should have this as a rotator is because converting like this is super messy and leads me to believe I'm probably doing something wrong. There we go. Uh-oh. Ah, yes, of course. Oh, yeah, that works. Store, rotate. Oh, made a mistake. Um, so we store the old rotation, and then we transform it by the new rotation here. Except that's not the new rotation, that's still the old rotation. We need to get the transform here so that when we use it, we're rotating it by the new rotation. That's very important. Okay, let's go ahead and build. There we go. Hot reload started. I'm not liking how long it's taking. Usually when it takes this long, it fails. But maybe I've just changed enough stuff that it's taking a while. I don't know. Twitch seems to have a lot of bots, don't they? I suppose it's not a lot. But out of 8 interactions, 2 of them have been bots. It's kind of odd. I wonder why my audio buffer's starving here in Unreal. I'll have to look that one up. I think I got plenty of memory left. Although I've got plenty of tabs, so maybe not. Let me check. Just need to make sure there's not anything important on this screen. Yep. So, plenty of memory left. 27 out of 31 gigs. Well, I got a lot in swap. That's probably fine. Ooh, that's fun. I can shrink HTOP down to where it's not showing anything except the load. Still compiling. This is taking long enough that I think I am going to go grab something. I will be right back. Ah, there it is. All right, I'm back. Compile failed. Of course, it gave me a beep right as I stood up. What don't you like? Oh, that was weird. I had a little red squiggly on the end of this, but I wasn't seeing an error up here. Let's try that build again. Ah, that worked. All right. So that worked. We have a build, but now we need to fix our pawn. After all my experimentation, she's a little messy. So I'm going to go ahead and leave the experiments up for now. So I can come back to them later. But I'm just going to move our events over to the side. And what I'm thinking is basically, I'm going direct in here. Add actor, local rotation, delta rotation. Did I miss a step? No, I didn't miss a step. I'm using the wrong function. I just realized I put the pawn on the wrong window. My bad, guys. Pawn comes over here. So, we don't want to add actor local rotation. We want to add rotation input. Okay, don't be context sensitive. That one right there. Not that. That doesn't exist anymore. Trying to use it would be problematic. Let's go ahead and make sure that we are inputting our flying pawn component. And we just want to go straight across. Just like that. Now, in the future, we might want to convert this to a rotator first. But for now, we'll do it like this. Well, bad news. It's not supposed to do that. Okay. So let's go ahead and set up our debug run here. That's concerning to me. We don't need rotator open directly. We can go ahead and drop debug right here to start with. And we'll go ahead, go to our debug tools, unmute those breakpoints, hit play. I don't know if we're going to hit a breakpoint here. Yeah. So got stuck somewhere, need to reload the editor. So that's fine. We can just exit. And it is now fully exited, I believe. So we can go ahead and run in debug mode. And I am quite willing to bet that it's going to fail to load our module. So that's a relatively straightforward fix. So if it does. It's thinking. All right, so let's close some tabs here. Close. Yeah, that looks like a problem. Yep. We got the dreaded module error. Fortunately, this is not too difficult to fix. gonna figure that out and close our thing here. We need to browse to our project folder, then head to binaries, Linux, and then scroll to the end here and Unreal Editor.modules. We're going to open with our favorite text editor. This actually isn't my favorite text editor, but it is a decent text editor. And we're going to delete all the numbers after our project name. So basically when we're doing hot reloads, it's going to add these numbers, and then when we're done with all the hot reloads, it cleans up all its symlinks, which is what it should be doing. That's good. But then it forgets to change this back. And it also doesn't have a good way to check on load where the... It doesn't have a good way to check on load if this is a valid file for this system. So I don't know how to, something I might look into doing is committing a patch to Unreal to fix this. This seems like a pretty straightforward patch. Basically, if on load project name, if we split the string here times the length of project name, and if that does not equal project name, then we need to remove here to here, right? That seems fairly straightforward, but that's also not very robust. If they change anything about how these file names works, that will break that. So I don't know exactly how they're deciding on file names or library names for this, and there might be a better way to do that one than what I described. But that better way is going to be more complicated too. Okay. Go away and launch. I think I saved that. Guess we're about to find out. That's lazy. And the editor is launching. Splash screen is on the other monitor, but you know, it is launching. Okay, while that thing is launching, I suppose we can take a look at this. So we're taking our pending input and we're saying get clamp to max size 1. We're taking the size of our pending input. Okay, I'm pretty sure our deceleration is wrong. Because this is just going to... No, that's fine. That's fine. We were... Okay. Add local rotation is adding to the position of rotation. So when we're deaccelerating from angular velocity, we're changing how much we're adding to that position. Which means I was way overthinking this. Right? And so our change in rotation should now be locked to the max pawn angular speed. No. Yes. Because we're subtracting off the difference between the... Yeah. Okay. Whoops. I want to remove this space here. Not the... There we go. You up yet, Unreal? Nope. 75%. Editor takes forever on this. Maybe I can look into getting an SSD. Probably not next week, but maybe the week after next. It's the week after next. Calendar's not pulling up. So one thing that drives me nuts about operating systems is that they will sometimes prioritize what they're doing over your input. I know giving the operating system input is going to slow down all the stuff that I'm doing, but the last input should always be the priority, in my opinion. Right? The OS should never be unresponsive. That's an impossible goal, but it should still be the goal. Okay. Yeah, I can probably buy, starting next month, I can probably afford an SSD. A big data SSD. Because, this is slow enough that I'm definitely thinking I need it. Or it'd be useful enough that it'd be worth it, rather. I don't need it technically, but it's taking a lot of my hours. Rotation acceleration times delta time. Uh-huh. So we're probably not unrotating angular velocity correctly. Looks right to me. There we go. Okay, we have a weirdness that I'm concerned about. It doesn't say that we're in debug mode. You know, it might not be a bad idea to get more RAM as well. So this is HTOP organized by memory usage. You'll notice that it says writer is using 25 gigabytes. And it's but my RAM usage is only 22 gigabytes, which means some writers in the page file, which doesn't sound like a good idea. Here we are. Let's go ahead and have you resume for a couple frames here, so we're really just into it here. first step over is taking a good long while. It's annoying. Yeah. Rotation acceleration doesn't have a value right now because I'm not giving it an input. That's fine. Oh, why do we have angular velocity? Uh-huh. This is so close to 0 that we don't care. But that's not. Oh, wait, what? Okay, so somebody needs to explain to me how these numbers become these numbers. Point 0.4, 0.13, 0.14. Do I need to step over this? Okay. Oops, what did I just do? Okay. Okay. Good news, the acceleration appears to be working. Or not. Appears to be slowly rotating at a constant speed. If I press any key, it stops rotating. Oh, if I press keys, it rotates correctly. Exceedingly slowly, but correctly. Right? These are the wrong rotations. This is supposed to be roll, not pitch, but it is pitching in the right direction. And same with this. This is supposed to be pitch, not yaw, but it is yawing in the right direction, meaning it's yawing in the direction of our local pawn. And so that's good. And then this is supposed to be yaw, not roll, but it is rolling. So this is rolling, but this is spinning, but no input is spinning. That's incredibly weird. Why would no input be spinning? So basically, if we're rolling through this set, we start spinning. Something looks like it's wrong with that, but I'm not sure what. Bad news. Still spinning. What? Where'd you go? There we go. Still spinning. There's my mouse. Did you just randomly stop spinning? That was weird. Turn on those debug symbols. Bang. Okay. So at this point in the game, rotation acceleration is a constant vector of 0, 0, 0. Correctamundo. Max pawn angular. Okay, doesn't like rotation acceleration. That's, well, no. Doesn't like squaring a 0? That's weird. Size is 0, so this should be 0. Max angular speed should also be 0. We should not be exceeding max angular speed. Angular velocity is greater than 0 for some reason that we don't understand. We want to check if it is greater than 0. And we have no, if we have angular velocity and no input, then we run this. I'm thinking that our problem is our clamp. Right now, angular velocity is a vector of that. And if we step over, did it change? No. Odd. Okay, well, let's go ahead and zoom. That's fine. We have some angular velocity. Oh, okay. I think I see what's happening here. We're never deaccelerating, only constantly accelerating. I'm a little confused as to why our inputs didn't change the direction of our acceleration, but we're only accelerating, so we're just getting up to max speed. It's a theory. It's not a very good theory. Get the breakpoints and resume so we can escape out. Okay, and then let's go ahead and rebuild. Definitely need to restart this computer. Rebuild complete. Well, it's not moving. It wasn't moving until I pressed some keys. I think our deacceleration is not working correctly. Yep, that's exactly what's going on. Alrighty then. Deacceleration. Okay. Let's go ahead and we're going to snip this a little bit just to make sure this isn't affecting us. If angular velocity psi squared is greater than 0, then we want to subtract a little bit from angular velocity. And the amount we want to subtract from angular velocity is going to be isn't this what we were just doing though? Angular velocity equals angular velocity minus the deacceleration. This didn't work either, if I recall correctly. Right, we want to subtract off a little bit of deacceleration. But I'm thinking, oh no. Okay, angular velocity can be negative. If we're just subtracting naively a positive from a negative, we're going to get all sorts of weirdness. So we want to get we want to do angular velocity minus angular velocity look at 0. The inverse of angular velocity? So angular velocity minus angular velocity is going to equal 0, right? Right? This is 0. No, that's not true. Angular velocity can be, well, no, if it's 3 negatives, then minus equals is going to, why did it fail? Whoops, wrong button. That was weird. Right, angular velocity equals angular velocity minus angular velocity. That works, okay? So we don't want to subtract angular velocity. We want to subtract some fraction of angular velocity. That is between 0 and 1. Is my deceleration between 0 and 1? Would you look at that? It's not. So okay. Pretty sure this goes in here. And the other thing that we want to be careful of is that this can't go below 1. So and you want to hear something horrible? Deacceleration is usually spelled differently than acceleration. Or I could be wrong about that. Maybe it just hasn't updated yet. Float max deacceleration. What's wrong with that? Is equal to the max between deacceleration and 1 point f. Right? And so we can, if we're lower than 1, we're 1. We can never go lower than 1. Okay? Let's build that. And would you look at that? We're rotating very slowly, but we can figure that out. Let's go ahead and actually start by just increasing the numbers on the pawn and see what that gives us. So I know it's weird for all you Windows programs out there, but please don't use client-side decorators. It makes your rendering system very janky. Okay. So, flying movement. Let's go ahead and set these. Oh, wow, these are very low. Let's go ahead and set the max angular speed to 100. Let's set the max angular acceleration to 10. Angular deacceleration, let's set it to 20. And save that. And let's see what we get. I don't really see much acceleration. Which concerns me. Let's go ahead and set acceleration down to 1. Set acceleration down to 0.1. Oops. Almost set angular deacceleration down to 0. Oh. I just realized something. It's going to be much better for me to somehow assert that deacceleration needs to be, well, deacceleration is backwards. A high deacceleration number is equivalent to a low acceleration number. All right, so if I bring angular acceleration down to 0.1, then I'm still not detecting it. That's concerning. Still not visible. So let's try 0.1. Why am I not seeing acceleration? All right, if I drop it down to 0, we should not accelerate. And yet we do. Oh no. We have a calculation error somewhere. In our acceleration and deacceleration? Okay, that actually, I can see that. The reason I can see it is due to this. This runs every time, and we are... I'm wondering if we're just... Let's go ahead and remove this. Comments are /NC, gentlemen. And C++. Rebuild. I think I need to look into clamping because I think I'm using the wrong clamping function. Or not? I'm quite confused. Okay, that's all fine. Angular velocity plus equals this. I am an idiot sometimes. You see that acceleration number? That's not the right acceleration number. You see that deceleration number? That's not the right deceleration number. Careful when copy pasting, gentlemen, or you might copy paste the wrong thing. What are these called? These are called angular acceleration and angular deceleration. I'm using the linear acceleration and the linear deceleration. That's not what I'm looking for. All right, let's rebuild this again. Input should do nothing. Wonderful. Okay. Let's go ahead and set the angular acceleration to 1 to start with. Didn't do anything. Oh. That means that acceleration number that we were using was 4,000. That's incredibly high. Okay. Not seeing acceleration. Okay, yeah, still not seeing acceleration. And worse, the acceleration is having effect on the max speed. That should not be what's happening. Um, it's always been confusing to me. Why are we getting, if we are exceeding, if we're exceeding the max speed, then the max speed is our velocity? Anyway. Angular velocity equals, we're just going to do what we did down here. Angular velocity equals angular velocity is all minuses all the way down. Angular velocity dot size minus huh? Um this is always a positive. And if we're exceeding the max speed, then this is always a positive. So if angular velocity is negative, this doesn't work. What is our deacceleration? Angular velocity times what if angular velocity size is only a little bit over max speed? Then we're going to speed up and slow down. I don't know. All right, acceleration is not working, but rotation is working, so that's a start. I am going to end the screen tonight here. I am extremely tired, and it's getting late. So thank you all for coming. Have a great evening.